We're going to talk about parent functions, and parent functions are just your basic functions with no transformations. We're going to learn about linear and squaring functions, cubic, square root, and reciprocal functions, step and piecewise functions. Let's start with linear functions. So we know what it looks like, a straight line. Our domain is negative infinity to positive infinity. We talked about how in class today there's no restrictions on that domain. We know that our y-intercept is 0, b, and our x-intercept is negative b over m, 0. We know that when our slope is positive, our function is increasing. When our slope is 0, the function is constant. When our slope is less than 0, negative, our function is decreasing for linear functions. Now for the squaring function, x squared, we already talked about how, again, there's no restriction on the domain. That goes all the way from negative infinity to positive infinity. But our range is going to be from that bottom minimum point to positive infinity. We can have decreasing sides and increasing sides of our squared function. We have one y-intercept always, but we could have 0, 1, or 2 x-intercepts depending on where this function lies on the graph. Let's talk about our cubic function, x to the third power. So again, there's no restrictions on the domain. That goes from negative infinity to infinity. It does have origin symmetry. We know it's an odd function. And we have some critical points. That middle point there is 0, 0. It's also going to pass through 1, 1, and negative 1, negative 1. As it's pictured in the graph, this function is increasing for its whole domain. Now this radical function, or square root function, it starts at 0, 0 because we have a restriction on the domain. Whatever's under our square root cannot be less than 0. It can be 0, it can be greater than 0, but it can't be less than 0, right? Because if we have a square root of a negative number, we get an imaginary number as our result. Finally, let's talk about that rational function, 1 over x. So we talked about a lot in class today about how that denominator cannot be equal to 0. So when we think about our domain, we have to think about what values of x would make that denominator equal to 0 and exclude them from our domain. We'll have an asymptote running at the y-axis and the x-axis in this basic version of 1 over x. We can see too that on both sections of the graph, our function is decreasing the whole time. And lastly, let's talk about the step function and piecewise functions. For this step function, the little symbol that we have, this is called the greatest integer function. So this function tells us whatever we input for x, we're going to find the greatest integer less than or equal to that number as our output value. So it's similar to rounding down. So the example I put is that if we have 0.25 as our x value, we're going to find the greatest integer less than 0.25. Integer is whole number. So the biggest number less than 0.25 is actually 0. So we can just think of that as rounding down. There are other step functions that require rounding up, and those are called ceiling functions. Now for the piecewise functions, we already talked about how we have a different function rule depending on what part of the domain we're in. So this one is split into 3 parts. X squared defines the function for all values that are less than or equal to 1 on the x-axis. 3 is our function for any values between 1 and 2, including 2. And then y equals x is our function that we're going to use for any value of x that's greater than 2.